Okay, today we're going to talk about the substitution rule for definite integrals, strictly really with the bounds. And for people watching this video, I want to caution them that this really isn't quite as accurate notation as what the book is using. Needs to go a little bit further in depth, especially if you're considering kind of looking at the AP exam requirements. But I would say that for what we are doing today, it is more than proficient. And for anything you're going to use further in calculus, this will definitely satisfy your needs. But concerning content for the AP exam, we're going to have to be a little bit more particular, and that will be for a different time, folks. So we'll look at that a little bit later. So for what we're going to do today, we can take the definite integral and we can rewrite it using substitution. And what happens is it becomes f of u, so we decide what an inside function is, and we switch it to du through our substitution. We're all used to that, right? Going from x to u. But if we do that, that changes the bounds. Because here the bounds are x values, x equals a and x equals b. Well, if we are going to change it to u, then we have to switch it to u. And so you take u of a and u of b. So whatever the function is for u, we plug in a and we plug in b, and it switches the bounds. And that can actually save a little bit of time for us in the long run. So I just have two short problems for us today to glance at, and then we'll try your assignment. So these should be easy, and these should be reviewed for you. Okay? If they're not, then maybe we need to spend some time after school talking about some calculus. I have u is equal to what? X squared plus 3. So du is 2x dx. All right? So I have an x there. Life looks good. I'm very happy. This doesn't look like a double substitution problem. 1/2 du is equal to x dx. And so I got 1/2 my integral du. And I can get rid of then the x and the dx. Those are my substitution pieces. I'm not going to write the bounds because the bounds are going to change. Instead of x squared plus 3 to the 4th, I write u to the 4th. No, u to the 4th. Okay, so very good. So now when we take the antiderivative, okay, before we take the antiderivative, Caleb, here's what we're going to do. We're going to change our bounds. Notice that u is x squared plus 3. So instead of 0 and 2, I plug these in and evaluate them for u. So u squared is 0 plus 3 is 3, and 2 squared is 4 plus 3 is 7. Those are my new bounds. I plugged in 0 for x squared plus 3, and I plugged in 2 for x squared plus 3. Thank you. All right, so what's the antiderivative of u to the 4th? Times 1/2 will be u to the 5th over 10. Now, here's what I do. Instead of plugging something back in for u, instead of plugging x squared plus 3 back in, I just evaluate it at 7 and 3. So I'm going to expect you to do this on the test. If I say change the bounds, you have to change them like that. You plug in 7, you get 7 to the 5th over 10. Plug in 3, you get 3 to the 5th over 10. And 7/10 is a big number. I'm just going to write this 7 to the 5th minus 3 to the 5th over 10. Only because you might see that it expressed like that on the AP exam. Okay. You could obviously come up with a decimal too. Well, you might see it like this. You might see it. Why do you not use a constant in this problem? Because it's a definite integral and you're evaluating. This does end up being a decimal because you're dividing by 10, so it'll be point something. It's not evenly divisible by 10. And then one last piece so we can figure this out. I quick want to talk about the mistakes that people make on the test. What mistake do you think maybe people make on the test with the bounds? Yeah, they just use 2 and 0. Or, here's the other mistake. They use 7 and 3, but they plug x squared plus 3 back in for u. Yeah, if I plugged in x squared plus 3 and I used, 2 and 0 instead, I would get the same answer because 2 squared is 4 plus 3 is 7. I mean, you can see how it works. It's just a way to work with this integral instead of plugging stuff back in. Some people find that better. It's not that big of a deal. Okay. But I'm teaching it to you. You might use it. Okay, second one, or example 6 from this continuing notes of 5.5. What is u in this problem? U is sine. And yeah, because it's cubed, so it's sine of x, that quantity cubed, times cosine of x dx. So I identify that sine of x is really the one on the inside. So that's how I make my choice. Most of the time, I would say if it's being taken to a power, then that's the one that you choose. Du is cosine of x dx. Do I have a cosine of x dx? Ah, it's right there, so I could just get rid of it and use du with my integral. It's a very simple substitution. Instead of sine cubed, I have... And now I'm going to change my bounds. What is the sine of 0? 0. What's the sine of pi over 2? 1. Antiderivative u to the third. U to the fourth over 4. Evaluate at 1 and at 0. So I got 1/4. Go Tigers. Yeah, it's really not that bad, is it? Just make sure that you're changing the bounds and using u. That's your practice for today. That's the last assignment I have for you folks. Here you go. What? What about what? What about C? Does he listen to anything I say, Sean? Fight him? Kick him out? All right, we'll see what happens. Ooh, wow. Ooh, holy cow. Fighting words. On a star quality day, a lot of negativity. Okay, before you write down the assignment, one last piece. I've gotten rid of these type of problems simply because they really don't come up unless we're dealing with AP content, which we'll bring it back up in a little bit. But I want you to know as you look at this problem, where is it discontinuous? At 3. Do the bounds cross over 3? So therefore, the FTC does not apply because the function has to be continuous over the given interval. So I've taken out those kind of problems from your assignment because I know that for some of you, you don't remember, for example, where tangent of theta is discontinuous. Happens to be at pi over 2, at 5 pi over 2, and at negative 3 pi over 2, so on and so forth, okay? So I haven't included those for that purpose, but we will deal with those later. Here's your assignment, 5.5, page 366. Those are your 8 problems. You have the rest of the hour to work. I'll hand out your homework cover sheet and your study guide tomorrow. Review activity in class. Be ready for your definite integrals.